Hello, ladies and gentlemen. Mr. Miller here with your Algebra 9 6.1 Day 2 notes. So today we're going to be bringing in our use of zero and negative exponents to simplify expressions here for today. So we got a couple warm-ups there, so go ahead and warm yourself up again to start. Refresh your mind on how we solve those. And we'll move into our new notes here. And again, you'll be always to check your answers there on Canvas. We'll have those answers posted. Anything to the power of 0 is always going to be 1, ladies and gentlemen. Always 1. So what do I mean? Anything. So if I have, let's say, m to the 0 power, that's going to equal 1. If you have 10 to the 0 power, that's going to equal 1. So anything to the 0 power always equals 1. No matter if it's letters or numbers or anything, always equals 1. Second part here is the negative exponent part. So if a base has a negative exponent, then you are going to flip it in the fraction. And make it positive. And I don't care where you flip it or where that negative is, you always flip it. So if the negative is on the top, you flip it, it becomes positive on the bottom. If the negative is on the bottom, you flip it and turn it to positive on the top there. So we're going to play around with this here and clean some up here and show you. So here we go. So again, hopefully your warmed you up there. So you're should be getting a little bit better on these. So if we get here, or at least remember them, when I have the power that's the same base, we're going to add our powers together. So here on the top, that's a 2 plus a 3, so that top turns out to be 10 to the 5th, all over 10 to the 5th. And again, from yesterday, remember that means there's 5 tens on top, 5 tens on the bottom. And again, our formula from that was if our bases are the same, we subtract. So we're going to use that formula just to make it a little easier, less writing. So that's going to be 10 to the 5th minus 5, which that gives us an answer of 10 to the 0, and 10 to the 0 is an answer of 1. So cleaning this up, sometimes they won't clean up to a power of 0, which that would have been like yesterday, but sometimes they will clean up to a power of 0, and when they do, that answer has to be 1. Working on our second one here. So again, our rule, a power to a power. Remember, that is multiplication. So that looks like this, 60x times 2. And again, that's all over x to the 12. So cleaning that up, we will have x to the 12 all over x to the 12. And again, some of you are seeing this right now. This is like saying, 3 over 3. Well, what does 3 over 3 clean up to be? 3 over 3 is 1. Or what is 10 over 10? That's 1. If you have exactly the same thing on top as you do on the bottom, which we do here, that's going to be a 1, no matter what. But again, showing our rules, that's going to be division. So it's subtracting the 2 powers, and 12 minus 12 gives us x to the 0, and x to the 0 is an answer of 1. There's a little funny one here. Math to the 0. Again, technically, how you should solve this here, I know it's all one word, but if it wasn't all one word and we're looking at this was an m variable, an a variable, a t variable, a h variable, you would have to distribute that. But again, m to the 0 power is going to be 1, a to the 0 power is going to be 1, t to the 0 power is going to be 1, h to the 0 power is going to be 1. I'm taking it all as one thing. So what's my final answer going to be? 1. All right. So here's where our rules come in, and they start overlapping a little bit here. So our rule here to clean this up is one of two things. We can use our property from yesterday, where when we're dividing, we're going to subtract the top exponent from the bottom one. So if we're doing yesterday's, it would look like this. This would be the same base as 6. You take the top one and you subtract the bottom one. That is going to come out to 6 to the minus 2. We do not like negative exponents, so we like to put them in terms of positive. So to rewrite this, we have to flip where it is. So remember, this is all over 1. That's the fraction. So we need to flip it. So I'm going to put this on the bottom and put the 1 on the top. So, and when I put it on the bottom, that becomes a positive. So it's 1 over 6 to the second. And that is my final answer. I am going to show you the other way, just to make sure that everyone understands what's going on here. Why did it become 1 over 6 to the second here? So remember, and I'll use blue pen for this. This is 6 to the third, which means that is 6 times 6 times 6 on the top. This is 6 to the fifth, which that means it is 6 times 6 times 6 times 6 times 6, 5 of them on the bottom. Well, what happens when we're multiplying in our fractions here? We can eliminate things that are the same. So those 6's eliminate each other, those 6's eliminate each other, those 6's. And remember, we make that 1's when we eliminate them. So what do we have left on top? We have a 1 left on top, and we have 2 6's left on the bottom, so that is 6 to the second. And again, talk to your Mr. Patel or Mr. Inch how they want you to clean this up, because this is a smaller one. They might want you to clean this up to 1 over 36 as a final answer. I'm going to leave it as powers because we're playing around with powers in all of this there. Next one. So again, this power here, ladies and gentlemen, has to go to everything. It's kind of the first time we've seen this one. It has to go to all parts. So this becomes on top x to the third times 2, because the power times the power is when we multiply, all over x to the 6 times 2. Cleaning that up, we get x to the 3 times 2 is 6, and then x to the 6 times 2 is 12. Again, subtracting. So our next rule, when we have division of the same bases, we have x, 6 minus 12. And again, some of you are seeing this already just from this. Oh, all 6 of those cancel on top. So I'm going to have a 1 on the top, and I'm going to take away, so I'm going to have a positive 6 on the bottom. There's going to be those 6 on the bottom. Again, just want to go through it formally. So this does come out to x equals to the minus 6th power. And again, that's over 1. Flip it, so 1 over x to the 6th. And that's our final answer. But again, some of you will see this with your eyes and be able to do quickly say, oh, yep, I'm going to have a 1 on the top because all those 6's, there's 6 x's that disappear as we're canceling them out. So I get 1 left on the top, and then I'm going to have 6 x's left on the bottom. Last one here, we have a 0 to the negative 7th. So kind of going through here, we don't like negative exponents. See if it changes to something that looks nice here. So again, that's over 1. So again, when we change that, that's going to come flip it. 1 goes on top, and then we have 0 to the 7th on the bottom. And unfortunately, 0 to the 7th is the same as 1 over 0, and you cannot divide by 0, so we will get an undefined answer for that one. So we get an ugly undefined. But it's good to know that anytime you divide by 0 again, that's an undefined answer. If you have a 0 on the top of your fractions, that's when you do get 0. Continuing here. Let's see, continuing evaluating our fractions here. I think I'll let you do the first one here because it's kind of a review. Obviously, we have our movement, so we're going to do the movement there. So I'll let you do that one by yourself to kind of clean that up there. Let's see, the second one, I think you should be able to do that one also and clean that one up. So let you see how you do on those first. Oops, can't even see them on my screen. How you do on those first two. This third one here, we really haven't seen one yet where we have an exponent on the bottom. That's negative. So again, when you're cleaning this up here, so if there is a negative, no matter where the power is, you flip the position. So you flip the fraction. So I'm going to flip my fraction. So 1 goes on the bottom, and then that 8 to the second goes on the top. And again, it's all over 1, so that cleans up to 8 to the second. And again, this is a small one, so we kind of tend to clean up the small ones. 8 squared is going to be at 64 there. And then the last one, you can do that one also. Let's get into the ones that are a little more challenging here. So putting everything together here, simplifying the expression, write your answer using only positive exponents, cleaning all of this up. So we're putting together everything we've learned the last 2 days in these. So you can start anywhere. I usually like to start, obviously, if we have any powers. I'm going to start with that, obviously, first. So even though I said start anywhere, you have to start with your powers. Sorry about that. So we're going to take care of that. So I'm just going to rewrite this part. And it is a fraction, and we're multiplying it all together. So I'm going to get a giant fraction here. So again, I still have 3 on there, and I'll put a little multiplication sign underneath that. I have an 8, an m to the 5. Again, we're just bringing it along. And now I'm going to take care of my powers here. So I tend to like to clean things up as we're going along here. So I might not just show the multiplication, but again, I'll show it here for this one, for this first one. So we get m to the 4 times 3, because it's a power times a power. And again, remember that goes to the top and also to the bottom. So on the bottom, we get an n 2 times 3. Cleaning this up again, we still have a fraction. 3 on the top. I'm going to get rid of that little multiplication sign, even though it's all multiplication, and start cleaning this up. So I have m. 4 times 3 is 12, all over 8. M to the 5th. And then n, I have 2 times 3, which is 6. I still have m's in here, so I need to go one step further. And again, you might actually do your work on the side so you can clean it up here. My fractions, I can't do anything with 3 and 8. They don't reduce any further. If they did reduce, we'd want to make sure that we do reduce those further. But I'll just do my work for the m's on the side here. M to the 12th minus 5 is the rule, so that's going to come out to m to the 7th there. So we'd have 7 m's left on top, so 3, m to the 7th, 8 on the bottom. Again, we canceled those out, and again, some of you see it right away that there's 12 of them on top and 5 on the bottom, so all 5 are going to disappear into a 1, so we don't need to add that one. And then we have an n to the 6th. And there's my final answer, cleaned up. Let's go ahead and work through these ones together, because we're still getting the hang of cleaning everything up here. So again, it's all fractions here, so I'm going to jump in to my giant fraction. So we multiply everything across on the top. I'm going to take care of my powers here. So I'm going to start cleaning things up mentally, because remember that 2 has to go to everything, just like this one has to go to everything. So there's 4 parts that goes to. This one has a total of 5 parts. It's got to go to that 4. So start cleaning things up. So 2 to the second power, I'm going to clean that up right away. 2 to the second power is 4. M to the 5th to the second, again, I'm going to clean that up just so I don't have as much writing here. So we know that's multiplication, so that becomes M to the 10th. There'll be enough time to go through stages here and clean things up. And then N to the 1st, which will turn into 1 times 2, is N to the 2nd. 4 to the second power is going to be 16, 4 squared. M to the 2nd to the 2nd, that's going to become M to the 4th. And I don't have any N's there. Go to my next one. We have an M to the 2nd, because that's 1 to the 2nd power. We have an N. 4 times 2 is going to be 8. And then we go down to the bottom. 5 to the 2nd power is, and I'm going to put a little multiplication in here because we're still all multiplying. So 5 to the 2nd power is 25. And then N to the 2nd power. So as you can see, there's quite a little bit here we still showed. Now we can start cleaning up again here. So I still have a 4 on the top. I'm going to combine my like terms on the top. That's what I'm going to clean up next. So I have M to the 10th and an M to the 2nd. So remember, we multiply when we do that. When we're multiplying, we add the exponents. It's not a power to a power, so we're not multiplying the powers. We are multiplying, yes, but the powers we just add. So that will become M to the 12th. Our N's here, again, this is all multiplication, but again, it's not a power to a power, so we add the powers together. So that's N to the 10th. 16 times 25, I am going to multiply those together, so that's going to come out to 400. And then we have just a single M to the 4th and an N to the 2nd. We can reduce our fractions. 4 goes into 400. So again, once, and we're left with 100. That 1 will disappear unless everything else disappears on top, which it won't. I have M to the 12th over M to the 4th. So again, I'm subtracting. So I'm going to be left with M to the 8th on the top. I have 10 N's on the top and 2 on the bottom. So again, subtracting. So again, I just had 8 there, and that canceled those out. 2, I'm going to take 2 away from that, so it's going to leave 8. So that's N to the 8th. And then all we have on the bottom is 100. So my final answer cleans up to be M to the 8th, N to the 8th, all over 100. So I'm going to give you some time here to work on this third one. So pause the video if you would, and work on this third one, see how you do on that. And then actually no, we'll do this one together and I'll let you work on this last one together. Change my mind. We'll do this one and then do the last one. So powers goes to every single part. So again, just cleaning that up. 3 to the 3rd. Here I have x to the minus 2 to the power of 3. So again, it's multiplication. So minus 2 times 3 is a minus 6. And then y, that's a positive number. So y, 2 times 3 is to the 6th. Again, here I have to move things. So I'm going to get a fraction because I have that negative exponent. So I will get 3 to the 3rd on the top. Y to the 6th stays on the top. But this minus 6 has to move to the bottom, so it is positive. So that gives me x to the positive 6. And again, this is kind of a small one, 3 to the 3rd. You guys should know that. It is 81, or get used to knowing that. 81 y to the 6th all over x to the 6th. Again, if they're really large exponents on a number, you'll just leave the exponent. For me, when they're a little bit smaller, you're going to clean that up. And that is my final answer. So we'll let you, just showed you an example of where that minus needs to go again. So take a moment to answer that one. And as always, please let us know if you have any questions, ladies and gentlemen.